Dear students, today we are going to discuss paper number 7, that is Technology of Milk and Milk Products, in which module number 30 is Technology of Dried Milks 2. In this we are going to discuss 4 different products. First one is humanized milk powder, then malted milk powder, then buttermilk powder and cream powder. Let us start with humanized milk. Milk is nature's ideal food for infants and growing children, except in rare cases of lactose intolerance. Mother's milk is not only desirable but essential from the time the child is born, and hence the baby is recommended to be breastfed until it is normal. It has always been an accepted fact that the best food for babies younger than 6 months is mother's milk due to the composition and content of various vitamins and essential amino acids. In each species, the milk meets the specific needs of the offspring. The milk of one animal cannot be a real substitute for that of another. Hence, the most ideal situation for infant feeding would be to feed the child with human milk during the early stage of his growth. However, situations may arise when a human baby may be required to be given milk other than from mother. The substitute of breast milk serves as a saver of precious life during vulnerable stages of infancy in the event of lactation failure, insufficient milk secretion, and in case of mothers inflicted with transmittable diseases like tuberculosis or breast cancer. Chemical composition of human milk differ from that of cow or buffalo milk. In the next 3 subsequent slides, we will discuss compositional differences in human milk, cow milk and buffalo milk. In this slide, we can see that protein content of human milk is less than that of cow milk and buffalo milk. The fat percentage of human milk is almost at par with that of cow milk, but buffalo milk has very high concentration of fat. The carbohydrate content, that is lactose, present in human milk is around 7%, which is very high compared to cow milk and buffalo milk, in which lactose content or carbohydrate content is in the range of 4.5 to 5.1%. The S content in human milk is very less, since infants have underdeveloped kidneys. The S content in human milk is 0.21% as compared to 0.72% in cow milk and 0.82% in buffalo milk. In this slide, we can see major differences in the makeup of different constituents of human, cow and buffalo milk. Let us start with protein content. Protein content is divided into 2 major groups, that is casein and whey protein. In case of human milk, casein is to whey protein ratio is 40:60, whereas in case of cow milk and buffalo milk, we can say the average casein is to fat whey protein ratio is 80:20. Human milk contains more amount of immunoglobulins and other constituents like lactoferrin and lysozymes. This type of constituents such as immunoglobulin, lactoferrin and lysozymes are responsible for immunity development in newborn babies. In case of lipid profile of human milk contains more amount of all the essential fatty acids such as oleic acid, linoleic acid, linolenic acid and arachidonic acid. Even human milk contains more amount of lactose, that is around 7%, compared to cow milk and buffalo milk, which is 4.8% and 5.1% respectively. The purpose of high amount of lactose in human milk is that lactose is responsible for brain development in newborn babies. Human milk contains less amount of minerals or ash content since the kidneys of newborn babies are underdeveloped and hence renal osmolar load will be very high on the underdeveloped kidneys. To prevent this type of situations, human milk contains less amount of calcium, phosphorus and iron. On the other side, human milk has more amount of vitamins such as vitamin A, vitamin E and nicotinic acid compared to cow milk and buffalo milk. Apart from these constituents, human milk has more bifidus factor, which is a natural prebiotic substance which will help growth of bifidobacteria in newborn babies. Till now, we have seen different constituents present in human milk. Now, let us discuss striking features of human milk. Human milk is easy to digest and it is very speedily digested in infant due to formation of soft curd. This happens because curd tension of human milk is less compared to cow milk and buffalo milk. Human milk has quite less load on the kidneys due to low calcium content. Human milk is easy to digest and faster absorption of casein occurs due to smaller size of casein micelles. Human milk has more lactose and more amount of polyunsaturated fatty acids, that is PUFA, and these two constituents help in proper development of brain. Another striking feature of human milk is its bactericidal and anti-infective properties. These two properties are due to presence of lysozyme, secretory immunoglobulin A and bifidus factor as well as lactoferrin. Now, let us discuss human milk substitutes. While human milk is superior for the newborn infant, human milk substitutes play a necessary role in infant nutrition when breastfeeding is not possible, desirable or sufficient. Since the advent of first commercial formula developed by scientists of Nestle Research Group in 1866, a wide range of infant formulas have been developed by the manufacturers. Amongst these human milk substitutes, in this slide we are going to discuss two types of human milk substitute, that is standard formula and second one is soya based milk free formula. In case of standard formula, cow milk or buffalo milk is used to replace or supplement human milk. To manufacture standard formula, the major adjustment is required for protein is to fat is to carbohydrate ratio. Since these three constituents are different in case of human milk compared to cow milk and buffalo milk. These standard formulas are subsequently fortified with vitamins and iron. The second type of human milk substitute formula is soya based milk free formula. In this, soya flour or water soluble soya protein isolates are used for manufacturing. They are useful for the infants which are allergic to milk proteins and they are having lactase deficiency, means if they are suffering from lactose intolerance, and infants who show signs of galactosemia. The third type of human milk substitute is specialized pre-digested formula, in which all the constituents used are in the form of pre-digested. They are meant for infants having a variety of nutritional problems due to digestive malfunctions, physiological underdevelopment or gastrointestinal infections. Usually nitrogen is supplied through hydrolyzed proteins, energy through easy to assimilate simple carbohydrates with minimum load on digestive enzymes. The fourth type of human milk substitute is humanized or materialized formula. In case of this type of formula, development of nutritionally superior formulas having varying degree of chemical and biochemical similarities of alpha S casein and beta lactoglobulin from cow milk or buffalo milk is carried out. In this type of formula, adjustment of casein is to whey protein ratio is carried out through technological means, and PUFA and mineral contents are fortified to match with that of human milk. Till now, we have discussed 4 different types of human milk substitute, in which first is standard formula, second is soya based milk free formula, third is pre-digested formula, and last is humanized formula. Approaches to manufacture human milk. New generation of nutritionally superior humanized milk formulas have been developed having varying degree of chemical and biochemical similarity with human milk. There are two basic approaches for this. The first approach is to remove or reduce cow milk or buffalo milk substances like alpha S casein and beta lactoglobulin through enzymatic treatments. However, alpha S casein is hydrolyzed in the digestive tract of the infant, and thus formula containing hydrolyzed casein may not serve any useful purpose nutritionally. The second approach is modification justifiable from nutritional angle. For example, adjustment of casein is to whey protein ratio in cow or buffalo milk so as to simulate. Now, let us discuss certain suggestions for improvements in human milk substitute manufacturing from cow milk or buffalo milk. The first suggestion is modification of proteins of cow milk or buffalo milk to make them similar to human milk in terms of whey protein is to casein ratio, that is, it should be adjusted to 60:40. This will help in enhancing nitrogen utilization and in minimizing renal osmolar load on the kidneys of newborn babies. The second suggestion is modification of triglyceride makeup of cow milk or buffalo milk fat so as to simulate ratios of various fatty acids such as short chain fatty acid, medium chain fatty acid, long chain fatty acid, as well as that of saturated to unsaturated fatty acids to that of human milk fat. This will enhance linoleic acid and vitamin E contents in human milk substitutes. Another suggestion is adjustment of proteins is to fat is to carbohydrate ratio. This will reduce the protein content and increase the carbohydrate content of cow or buffalo milk and make it similar to that of human milk. Another suggestion is modification of calcium is to phosphorus ratio as well as reduction in total S content. This will enhance mineral utilization and minimize renal osmolar loads in infants. One more suggestion is enrichment of cow or buffalo milk with factor to support growth of Bifidobacterium bifidum in intestines. We can also modify cow or buffalo milk with lactoferrin, transferrin and immunoglobulins to promote resistance towards enteropathogenic bacteria and to enhance iron absorption. The last suggestion for improvement is partial substitution of cow or buffalo milk fat with oils rich in polyunsaturated fatty acids as well as use of carbohydrate sources such as maltodextrins may also help in reducing the cost. Till now we have discussed striking features of human milk compared to cow milk and buffalo milk and suggestions to improve composition of cow milk or buffalo milk in such a way that they are suitable for infant milk consumption. Now let us discuss achievements so far for humanization of buffalo milk. Through technical means, scientists are able to modify buffalo milk in terms of its composition to simulate human milk. The first achievement is alpha S casein reduction to human milk levels by use of proteolytic enzymes such as rennet or trypsin. The second achievement so far is total protein concentration reduction of cow milk or buffalo milk to human milk levels by proteolysis. Third achievement is reduction in calcium levels by electrodialysis method. Curd tension of human milk can also be reduced by ion exchange technology to make the milk, cow milk or buffalo milk, which is easily digestible once ingested in infants. The level of unsaturated fatty acids can be improved by corn oil fortification with milk fat. In this flow diagram, we can see preparation of humanized buffalo milk powder. To start with, we can take skim milk, and this skim milk is subjected to electrodialysis processing, in which calcium is reduced up to 50%. Now, this electrodialyzed milk is incubated with proteolytic enzyme trypsin at the rate of 1.75 milligram per ml, and it is incubated at 37 degrees Celsius for 30 minutes. This enzyme trypsin will proteolyze the milk and reduce alpha S casein, and we will get proteolyzed milk. This proteolyzed milk is then pasteurized at 72.5 degrees Celsius for 15 seconds to eliminate pathogens present in milk. Now, this alpha S reduced pasteurized milk is homogenized with corn oil and coconut oil as well as lactose. This homogenized milk is then subsequently condensed under vacuum to 40% solids, and then vitamins are fortified. This condensed milk is subsequently spray dried to get humanized milk powder. The final formulation contains protein 15.75%, fat 23.07% and lactose 53.77%. The second important dried milk is malted milk. A British pharmacist, James Horlicks, developed idea for an improved wheat and malt based nutritional supplement for infants. In 1873, James and his brother William formed a company to manufacture their brand of infant food. The company originally marketed its new product as Diastide, but trademarked the name malted milk in 1887. Despite its origin as a health food for infants and individuals which are invalids, means they are suffering from certain disorders, malted milk food found unexpected markets due to its nutritive value, convenience, digestibility and palatability. It is also appreciated for its lightweight, non-perishable and high calorie qualities worldwide. Malted milk is a powdered food product made from a mixture of malted barley, wheat flour and whole milk, which is evaporated until it forms a powder. Malted milk food involves use of malted barley. To manufacture malted barley, malting is a very important step. It is also known as germination. Malting is a process applied to cereal grains in which the grains are made to germinate by soaking them in water and are then quickly halted from germinating further by drying or heating with hot air. Thus, malting is a combination of two processes. The first process is sprouting process and second process is kiln drying process. Malting grains develop the enzymes that are required to modify the grains starch into sugars, including monosaccharides and disaccharides. It also develops other enzymes such as proteases, which will break down proteins present in the grains. Now, let us discuss drying of malted milk. The malted milk food is generally prepared by tray drying method under vacuum, which is essentially a batch operation and hence adds to the cost. Spray drying method reduces cost of product owing to high volume of continuous and automated operation. Thus, the production of good quality low cost malted milk food with improved physical characteristics appears to be better proposition than continuing with the traditional tray drying method. The method employing spray drying process is shown in this figure. Crushed barley malt is taken and it is steeped with addition of wheat flour and water. The steeping process with addition of water will start enzymation process. In this process, enzymes present in barley malt will start acting upon starch and protein present in barley malt as well as wheat flour. The enzymation process is subsequently inactivated by applying heat treatment to deactivate the enzymes. Then this mixture of barley malt, wheat flour and water is filtered to separate out husk from the wort. Now, this filtered mixture is known as wort. The wort is then added with milk. After mixing wort with milk, the pH is adjusted to 7.0. The pH adjusted mix is then forewarmed and then it is condensed under vacuum. This condensed wort milk mixture is then subsequently spray dried, and this spray dried malted milk powder is subsequently packed and stored. Another dried milk powder is buttermilk powder. The method of processing of dry buttermilk by either the spray or drum drying process is similar to that of manufacture of non-fat dry milk, which is also known as skim milk powder. Care should be exerted to cool the buttermilk to 4 degrees Celsius immediately upon drainage from the churn. Since churning is carried out at around 10 to 12 degrees Celsius, so buttermilk will also have that temperature 10 to 12 degrees Celsius, and hence the buttermilk separate butter grains has to be chilled to 4 degrees Celsius. When intended for human consumption, buttermilk should be stored in a stainless steel lined tanks. A common practice is to preheat to 32 to 49 degrees Celsius and separate the buttermilk to reclaim a portion of fat. Since buttermilk will also have some fine butter granules, the buttermilk is preheated and at this temperature 32 to 49 degrees Celsius, the fat will be in liquid state and it will be easy to separate them out. The preheating is then continued to 85 degrees Celsius with a 15-minute hold to pasteurize the buttermilk. After increasing the total solids by condensing to 16% in case of drum drying process or 40 to 45% in case of vacuum condensing systems, which will be ultimately spray dried. The concentrate is preheated to 71 to 79 degrees Celsius and dried to a moisture content of 3 to 4%. After sifting through 12 mesh size screen, dry buttermilk is usually packaged in kraft paper bags with a plastic liner or in a fiber drum with or without a plastic liner. The last important dried milk powder is cream powder. Cream powder means the product obtained by partial removal of water from cream obtained from milk of cow and or buffalo. The fat and or protein content of the cream may be adjusted by addition and or withdrawal of milk constituents in such a way as not to alter the whey protein to casein ratio of the milk being adjusted. It shall be of uniform color and shall have pleasant taste and flavor, free from off flavor and rancidity. Since cream is a high fat product, occurrences of rancidity would be common. So, it has to be handled in such a way that it is free from off flavor and rancidity. It shall also be free from vegetable oil or fat. Since we are labeling it as cream, it should be devoid of vegetable oils and fats, other mineral oils, added flavor and any substances foreign to milk. So, cream powder should be prepared only from cream without addition of vegetable oils or fats or any other flavor into it. Dear students, in this module number 30, we have discussed 4 different types of special dried milks, that is human milk substitutes, that is human milk powders, second is malted milk food, third is buttermilk powder and last one was cream powder. Thank you.